Welcome back. This is CYBR 4220, presentation number 5 over databases in Postgres. And as always, I'm Kevin Burnside. Alright, what is a database in general? When everybody thinks of databases, they automatically think of SQL databases. Loads and loads and loads of tables upon tables upon tables of names, dates, numbers. Use fancy things with them as well. But by definition, they're an organized collection of data, not information, data, raw data, facts, structured, electronically stored, and they use other information to become, or use other pieces of data within the database to become information. We'll go into that here in a little bit when we get to relational databases. They're usually managed through a database management system, DBMS. The combination of the DBMS and data creates the database. You have to have both to really have a database, or else you just have a blank collection of data with no rhyme or reason. It allows secure access across multiple users, and it's designed to hold extreme amounts of data. I think some of the non-relational databases are up to petabytes at this point, which is mind-blowing because I was born in the 80s. A megabyte was a breakthrough. Gigabytes, were bigger breakthrough, and now they're talking about petabytes. So it's actually been pretty amazing to see the growth of this. Because when I didn't think we had a computer in my house until I almost graduated. Going to talk real quick just about the database management system. System used to create and manage databases, usually comprehensive. I'll go into comprehensive in my last line, exactly what that means. Software based, you really don't have too many hardware based database management systems, unless you call those little things where the little frames, the little abacus. I guess you call an abacus a hardware database management system in a way. Anyways, it serves as a direct interface between users using high-level language like we speak and the data, which is stored in low-level language. When I said comprehensive earlier, what that means is it allows users to retrieve, update, modify, alter, and manage the information, organization, and content. So it's an all-inclusive. It doesn't just do one. It's not just like POP3 and STPMS where they just do one or the other. Database management system covers all of it. We have types of databases. Give me a second. Sorry, mouth is getting dry. Types of databases. Usually people just refer to types of databases either relational or non-relational. Really, you can kind of codify and categorize databases by organization, by data organization, which is relational, non-relational, columnar, wide columnar, or information type. Is it graph? Because graphs are stored differently than numbers are. Just the time series, the document. A lot of legal entities, lawyers' offices, legal departments, HR departments have document databases, which are almost all object-oriented. Object-oriented databases are used a lot in Java programming, some C++ programming, where the subject, the key, and all the variables are all stored as one object. So that's stored differently, and those are using non-SQL. I want to hit on Columnar real quick. When I was looking at Columnar and thinking about it, it said it was used in warehouses a lot. When I started thinking about it, it's set up like a warehouse. If you go into a warehouse, you have rows and rows, or columns and columns and columns and columns. If you don't have rows, if you go into one column and then you look left or right into the other columns, which would be your rows, there's not going to be any connection between those rows. It's all in a column. Now it is query efficient because any piece of information is just in the one column, so it can just avoid and ignore any other column. So it was just a good analogy between the two. Now we were going to focus on relational and non-relational databases as far as the types of databases. Postgres, which we're going to be using in our labs, is a relational database. Our servers, I shouldn't say labs, just our servers, is a relational database. Relational databases are useful for businesses, especially accounting, inventory control, even personnel management. I use one in my role as a training coordinator. Well, about to be an divisional HR rep or training rep, but still I use a relational database to keep track of who and where, because I have 800 people I have to keep track of. So I keep track of them by our primary key is, are they on the asphalt side, or are they on the milling side, are they in the plant, and then the foreign key would be their their supervisor would be their foreign key. But we'll get back to that in a second. I'm jumping ahead. Relational databases using multi-column, multi-row. You got table, record, field. I mean, everyone in this class has seen an SQL database at some point. I mean, everyone's used Excel at some point, which relational database right there. Usually relational databases are almost always SQL based, and they operate on keys, like I was saying earlier. With my people, their primary key is what section they work in, and their foreign key, which is their secondary key on their main table, primary key on their subtable, is going to be their supervisor. And there's other keys. I did see in some of the things I looked at where people were talking about, oh, it allows for redundancy. Part of normalizing database is actually reducing redundancy. So yes, I do have information in one or two places, but we try to keep that as small as possible, because when it comes to an SQL database, you want information just in a narrow focus of places. So it's easy for the system to find, it's easy to keep track of, it's easier to update, and relational databases have a scaling problem. They're very information intensive, and you can scale vertically, but with relational databases, it's really hard to scale horizontally. Vertically would be like adding additional floors if we're building a building. Horizontal would be just adding more buildings. Relational databases like to be all in one server, one database, one place. So non-relational databases, often referred to as no SQL databases. SQL, SQL, however you say it. I've went through 3 different universities trying to get my degree done, and I've had professors say every different way. So usually most people say SQL, some do say SQL. Anyways, data is stored without tables. Key value store, it's a key value store, like a barcode system at Walmart, or anywhere. Just basically when they scan the barcode, that's their key, and the value is all the information that the barcode is going to pop up. It's going to be the name of the item that they scanned, the price, maybe a shipping manifest or order manifest, or who the item's going to. Museums use a non-relational object-oriented database as well, where everything is tagged somewhere on it. It's got a scan bar that goes with it. They scan it. It tells them who donated it, who it gets shipped back to, if it's getting shipped out, if it needs to go to restoration. So, and like next line, object-oriented is a good example. Any kind of programming database, because programmers do keep a lot of the programs they're working on, a lot of their pieces of code or parts of code they might reuse or they're working on separated in a database, and they keep the key value, which is the program or part of the program or function they're working on, and then the value, which is all the pieces of the code that go with that function. Columnar is another example. Non-relational databases are usually free and open source. They have better horizontal scaling, which allows for more users quicker, because you can, with non-relational, you don't have to connect one table to another. Everything's kept independent. So you can basically add more houses. It's easier to add more houses and put information in a bigger network. Postgres SQL, usually just known as Postgres. It's SQL relational, free and open source. Default port is 5432. I'm sure one of the other people in the class is going to make a very detailed analysis of how to install it. A lot of people do. They do really well. Drew does really well. Dylan does really well on that. So I'm maybe going to try to go over that. I will go over some good hardening recommendations here in a second, though. Okay, Postgres hardening part 1. IP table rules. A lot of the hardening does come down to IP table rules and just rules in general. It's either Postgres configuration file or IP table rules are your two biggest ways to harden Postgres. Got a list of commands just for one section here. All of these commands on this page all work towards one thing. And this is just shutting out and making sure that, like we do with every other program, only the open ports and only the ports needed and only the connections needed are allowed in or out of our server. For this one, first one is just maintain established connections. If you don't want to cut those off, because some servers are on all the time and they have 24/7 connections running at all time, and you don't want to just have them drop. The next one, which we'll also reuse in our next presentation for SSH, is allowing port 22 is our SSH port, which will be opening up. The next one is to the port 5432, opening that up, allowing that. And then the last three are outbound rules that drop everything else that doesn't specifically connect to another specific rule. That's why we have a rule right here for port 22 and port 5432, so that they can connect directly to those ports, but if they're not looking for those ports, it drops your connection. Hardening part 2. Second recommendation is restrict the listening addresses. This is not something that I will probably do in our labs, but if I did work in a position where I was a database or sysadmin, then yes, I would take the list of interfaces or approved vendors, subcontractors, whatever IP addresses I had approved to connect into our system, especially our database, because databases are like holy grails for hackers and offensive actors. I mean, it's filled with the most valuable resource known to man today, which is data, information on usually people or enterprises, and that is valuable. Usually condensed as much as possible, so much faster to bust in, grab, and get out. So the restricting listening addresses means that your Postgres is there, is listening for connections, but it's only listening for connections from XYZ IP addresses that are subcontractor 1, head office 2, and office managers home office 3. So, and that's all done through the Postgres configuration file. And it's just, there'll be a comment line, it's going to have the little hashtag listen address going to be blued out. Take the hashtag off, and then listen address equals, and change that little star symbol into the list of addresses that you won't separate them by spaces. Nice, simple, easy. Make sure to write out before you exit. I have a problem sometimes where I'll make a change and then I'll exit and I go back and save it, and of course not. That would be too easy if I did. Last hardening recommendation is require TLS. This is done through a config. That should be a CONF, not a CONG at the end of that. That's my fault. So please be aware that I'll change that before y'all even see it. So gonna add line host SSL all 0.0. It's very long. It'll be at the very end that you'll edit, and then you're going to amend the line host all 127. You're going to change that ident to trust on that line, and that'll configure it to require our TLS certification that we should. Some of us already have on there. If you don't, you will soon. And that's it on this page. Sources cited, just real quick. I'm sure there's a lot of good source cited. That last one though, that YouTube video, if you're having a problem understanding how non-relational databases work, and I've used them, I understand them a little bit, but always good to find another source. I was looking around for a good source that kind of broke it down, and I watched that video. It's just a few minutes long, but it's really easy to understand and follow. The format was really good. I wish I'd had that 3 years ago when I started cybersecurity as a major, because it would have taken a lot of heartache out of my earlier classes. So take a look at that.